Welcome to Lesson 5 of Module 1. Today we will be covering AutoML and AutoGluon. Today, we will explore AutoML with AutoGluon, an Amazon AutoML library. Then, since this is the last lesson in this module, we will briefly review this module's material. Let's start with AutoML with AutoGluon. To begin, what is AutoML? AutoML codifies ML best practices for data preparation, algorithm selection, and model training. This approach automatically preprocesses data according to its type, splits data into train, test, and validation sets, finds the best performing models, and finds the best model parameters. AutoGluon is an open-source AutoML library developed by Amazon. AutoGluon adheres to three key design principles: simplicity, robustness, and predictive timing. Users can train models directly on raw data without needing the details about the data and about ML models, simplifying the workflow. It works with a variety of types of datasets and handles model training failures automatically, making the library robust. Finally, it uses predictive timing, returning the results within the time budget specified by the user. With just 24 hours of training time, AutoGluon outperformed 99.3% of data scientists who participated in Kaggle competitions. Kaggle is an ML and data science community with tools and resources, such as ML competitions, designed to help you get started and complete data science projects. This remarkable achievement showcases AutoGluon's exceptional capabilities in automating machine learning tasks, enabling it to surpass the performance of highly skilled data scientists within a relatively short training period. Additionally, AutoGluon also achieves the highest raw accuracy among AutoML frameworks when directly predicting class labels rather than probabilities. The graph displays the percentile rank on the leaderboard for various datasets, comparing AutoGluon's performance against other AutoML frameworks such as AutoGluon, Jupyter, AutoWeka, and H2O AutoML. AutoGluon consistently outperforms these frameworks. Coding with AutoGluon is remarkably simple and efficient. You only need 3 lines of code to train and apply a model with tabular data, such as for our book price prediction task. To learn more, you can go to the GitHub repository or to the AutoGluon documentation. This slide shows the code to install AutoGluon. The first 2 lines ensure that the system to install Python libraries are up to date. The tool that allows users to install Python packages is called pip. Setup Tools is a library for packaging and distributing Python applications. Wheel is the standard for distribution of Python libraries. Updating these ensures that the 3rd line runs properly to install AutoGluon. Once AutoGluon is installed, it only takes 3 lines of code to train and use an ML model. For this tabular example, the tabular predictor is imported. The model is fit on the training data, and then predictions are made for the test data. Let's make this more concrete. In the 2nd line, the label in the training dataset is specified. In this example, it is price. The model fits on the training dataset to learn the rules using the fit method. Here, the training dataset is called train.csv. Then, the model predicts the label in the test dataset called test.csv. The fit method is a powerful feature that automates several key steps in the machine learning workflow. It preprocesses the raw data by identifying the type of each feature and converting it to numerical values. This is crucial as many machine learning algorithms require numerical input data. The method then determines the type of prediction problem, such as whether it is binary classification, multi-class classification, or regression. Based on this, it appropriately splits the data into training and validation sets, or performs a k-fold cross-validation split. It also individually trains various base models and creates an optimized ensemble that outperforms all the individual models. AutoGluon is a powerful tool that extends beyond tabular data. It also excels in image-related tasks such as image classification and object detection, and in text classification. Next, we will explore how to train models using AutoGluon and make predictions on new data. Lab 3 focuses on training a model using AutoGluon. In Lab 4, you will learn how to use the trained models to generate predictions on unseen data. Lab 5 presents an optional challenge, where you can repeat the training process with more data and additional training time to improve model performance. This hands-on practice will solidify your understanding and skills in leveraging AutoGluon for effective machine learning model development and deployment. Let's review what we have learned in this module. Module 1 provided an introduction to machine learning and covered several foundational topics. We began by defining ML and exploring its key components, including data, models, and algorithms. An example application was presented to illustrate how ML can be leveraged in real-world scenarios. Next, we introduced Jupyter Notebooks and SageMaker, two essential tools for ML development and deployment. Jupyter Notebooks allow for interactive coding, data exploration, and model prototyping, while SageMaker is a fully managed service that simplifies the process of building, training, and deploying ML models. We then delved into the different types of ML, such as supervised and unsupervised learning, and discussed the characteristics of successful ML problems. This included understanding the importance of high-quality data, well-defined objectives, and evaluation metrics. Common application domains for ML were explored and real-world examples were provided to demonstrate the versatility and impact of ML across various industries. We then introduced ML Lifecycle, a structured approach to developing and deploying ML solutions. Finally, we provided an overview of AutoML and the AutoGluon library, which aim to automate and streamline various aspects of the ML workflow, making it more accessible and efficient. The next module will focus on core topics related to dealing with tabular data. The key areas covered include exploratory data analysis, EDA, data engineering techniques, optimization methods, regularization approaches, regression models, tree-based models, and ensembling. Thank you for watching Module 1 of Machine Learning through Application.